classic steelmaking process typically begins with an electric arc furnace EAF, follows by LF in the VD, VODC, CM, and a rolling mill. This video will clearly explain the entire steelmaking process. Let's witness this amazing process together with CHNZBTECH. First, scrap is collected in the yard, loaded into a bucket, and transported to the melt shop. After passing through the metal detector, crusher, and magnetic separator for triple purification, ensuring zero plastic and zero danger. Then the treated scrap steel is put into the electric arc furnace. Next is the power-on moment. A graphite electrode with a diameter of 800 millimeters is inserted into the furnace. Arc discharge occurs through the electrode. 30,000 amps of current triggers a plasma storm. The high temperature allows scrap steel to undergo reactions such as melting and oxidation, and a large amount of gas and impurities are also discharged. During their movement, collide with the liquid steel surface. A loud and sparking scene is produced when the scrap steel in the furnace is completely melted into liquid steel. Then use a ladle to transfer the molten steel to the refining furnace for reduction and refining. In the refining furnace, first, the molten steel is homogenized by argon stirring and heat the liquid steel with an electric arc. The limestone added simultaneously generates slag at a high temperature of 1550 degrees Celsius, which reduces sulfur content by 90%. Liquid steel needs to be further purified in the VOD system to remove hydrogen and oxygen, thus eliminating internal cracks in the steel plate. The refined pure molten steel is transported to a continuous casting machine through a water-cooled crystallizer to quickly solidify the molten steel into slabs. During this process, cooling rate and drawing speed need to be precisely controlled to ensure that there are no cracks inside the billet. Segregation-free compact structure. The formed slab needs to be polished to remove the surface oxide scale. Then it is heated again to improve the tensile strength of steel structures during rolling. Then the blazing slab enters the mill, is rolled to the target thickness at 1200 degrees. It is refined to enhance strength. Steel plates are usually required under giant rollers, rolling dozens of times to reduce the thickness to 1/20th. The steel plate with the required thickness re-enter the thermal straightener for further straightening. The final steel plate is extremely straight and smooth. Finally, it needs to be checked for internal defects by ultrasound. Laser thickness measurement ensures dimensional accuracy. Mechanical tests verify tensile strength. Only the steel plates that pass the strict inspection can embark on the journey of building bridges, ships, or skyscrapers. This is the entire production process of giant steel plates.